we have a MacBook Pro. It's a 15 inches, and it's no power. So this is a late 2012, early 2013 15 inches. This is the first Retina that Apple made in terms of the 15 inches, A1398. This is the first the first line of Retinas of the 15 inches. Now, for this particular one, for the A1398, the board number will be 820-3332. Just going to confirm that. So board number will be 820-3332. Let's see if that's the case. 820-3332. Okay, yeah, it is. Now, with this particular one, if you have an issue that it's no power related, the first thing you want to confirm is this, because okay, yes, this is coming from another company, and they obviously, I suppose they already tried to do the repair and it didn't work. That's why it's here. And one thing that we see is it has no back screws, and then the battery it's definitely a Chinese battery. But the one thing you want to look out for if you happen to have an issue with A1990, this particular one, A1989, usually when the client says the device has no power on. Say that again? No, A1398. No, it's A1398. So usually when the client says that the device does not turn on, sometimes what they mean is that the device does not post. So what you will find is the device will actually power on, but there will be no feedback in terms of there will be nothing on your screen and you will have no keyboard response. And oftentimes that is because of this guy here, that is because of U8900. Now, U8900, it's a common failure on the A1398. Now, this is something that you want to look out for on the late 2012 and early 2013. Now, U8900, it's a common failure on these devices, and basically what it does, it basically prevents your GPU from responding on the machine. When that happens, the machine behaves in different ways. Sometimes the machine powers on, you have the fan spinning, but it's there will be nothing on your screen. Sometimes you have the device will actually post in terms of you get the device chimes, but there's nothing on your screen. Sometimes it will prevent itself as though it's an issue of no backlight. But so if you happen to have a problem, as a matter of fact, U90, because of U8900, there was a recall on the 15 inches. Apple had to do a recall on the 15 inches for people having the issue of U8900 to bring the device back, and then Apple had to find a way to address it. And obviously, given the year of the machine, it is long past the recall period. So if you have a problem, say especially the device powers on, fan spins but it doesn't post, or it tries to post but you don't get anything on the screen, the first thing you want to do is to try to address U8900. Now, also with this device, if we check the device, if you check the device and you get fan spin at all, then you just have to know that 9 out of 10 you are having issue with U8900. And then one of the ways you can confirm that is you can do a slight reflow on the chip itself. So if it's U8900, and the way it fails is over time, U8900 tends to disconnect from the main board. So the pins tends to disconnect. Although it's a QFN package, it's not a BGA package. The pins, the pins tend to disconnect from the board. Now, when that happens, you will have the chip itself loses communication with the board. When you reflow it, then the connection, you can re-establish the connection by doing a reflow on the chip. So if you doubt that, so one of the ways you do the troubleshooting is first by trying to basically reflow The chip itself doesn't fail. It's not the chip itself does not fail. So what the manner it fails is just you get it's almost as though the chip itself desolders itself from the board. So it's not like the chip itself is faulty. So uh, and the only time you should blame U8900 is if the device at least starts. Now, there are some very rare occasions where the device does not start at all and it has something to do with U8900, but that is like 1 out of 10. If most of the time, if you have a problem that is U8900 related, the device will at least power on. At least you will get the fans to spin. So let's get to know. Let's see what this one, what this is, and this is the machine actually still look very clean given the year of the machine. Okay, so let's see. Let's connect charger to it. I mean, on some other devices, typically I wouldn't connect power to it, but this is different. So I'm just gonna go ahead and connect power to it. Charger is connected. We don't have LED communication, so let's just confirm that the charger itself it's low. Okay, so we don't have LED communication. So what I want to confirm is I want to see if I have PPDC in voltage. So PPDC in voltage will allow me to confirm if at least I have charger voltage connected. So let's open up the schematic. Okay, before the schematic, we can go to the DC jack. So let's go to the DC jack. The DC jack is going to be on the other side of the board, J6900. Now, with my charger connected, I should expect my voltage, my charger voltage on pin 1 and 2. On my pin 1 and 2, where, let's see, where can we get, okay, pin 1 and 2, the fuse, okay. Let's see, what can we, trying to see what we can get on the other side. Okay, so on the other side of the board, we should have charger voltage by Q7080, and we can use C6912 to see if we have charger voltage. That will tell us if at least the charger itself is making contact, or if charger is it's properly connected to the board. So C6912 should be this guy here. Let's see that. 16.62. Okay, yeah, it means we have charger voltage. Okay, so now we don't even have LED, which is one wire circuit. The one wire circuit is not even active. In this case, this has nothing to do with your U8900, because if it was U8900, you will have charger communication. The device will start, but obviously it will not post, or sometimes it posts, but there will be nothing on your screen. So, but in this case, we do not have one wire circuit. So one wire circuit basically allow your charger to fully communicate with your device. In that case, your LED on the charger will be on. The fact that the LED on the charger is not on, it means that we do not have a one wire communication. So one thing, the next thing we want to do is we want to see what is it that we have on our PP bus. What we get on our PP bus will tell us if we have an issue with the SMC or not. So let's see what we have on our PP bus. Okay, we have 0 on our PP bus. Okay, so this is we obviously have to take the board out to see if we have the basic voltage required. So let's take the board out. Most of the screws they use are mismatched. It's not supposed to. That screw has no place in this machine at all. There's nowhere in this machine that you're supposed to have that screw on. screw here, it's completely wrong. That's not supposed to be there. Mm. And also one out. Okay. So wrong screw. That's going to be thrown away. Here's a okay. Let's just do a bit of so this is what I was referring to in the U8900, and it also appears that there has been previous work around U8900. You see that it's been previous work around U8900. However, the issue that we're currently having now has nothing to do with U8900. First, we need our board to get to the stage of a U8900 function being required before we can worry about U8900. So right now, let's see if we can get a pull up the schematic. So it's 820-00. 820-3332. Okay, here you go. Now, so let's basically let's understand what's happening here. So, in order for us to commence the troubleshooting, we started by connecting charger to it. We connected charger to it. We confirmed that we have PPDC in. Let's just confirm that. Let's confirm that we have PPDC in. So charger is connected. Okay, we have our charger connected, and we don't have communication on the charger. Now, this is not the same like the MacBook Air where you have a cable to complete the communication, the IO board cable. Now, with this one, there's no cable required for the LED to be active. The fact that we don't have LED, we are not going to worry about anything else. We are going to adjust the LED the absence of the LED first before we worry about anything else. Now, what we are going to do is we are going to follow the sequence of how the LED is supposed to be generated. So the first thing we want to establish is that indeed this charger, we get the voltage from this charger is making its way to the board. Now, one of the ways we do that is by checking. So on our on the board itself, we will start from the DC jack itself, which is J6900. So let's see here, we can easily type J6900, J6900. Okay, so J6900. Now, this is J6900. Okay, so on our J6900, we will have voltage on pin 1 and 2. Charger voltage will be on pin 1 and 2. Here it says 18.5 volt. Understand that 18.5 volt is going to be determined by the output of the charger. So if you have, for example, 18.5 volt, that is the rating for the 15 inches. That is why it says 18.5 volt. And also, one of the ways you can get the rating, it's by checking the, let's see. So one of the way you can get the rating of the charger that is meant for your machine, it's by checking this here. So here you see where it says, let's see where it's the guy here. So it says it's rated to 20 volt. So you see here it says it is rated to 20 volt. So the rating it says 20 volt. Now, on the schematic itself, it says that you are expecting to have 18.5 volt. Now, what that means is, because it says you're expected to have 18.5 volt, when you connect your charger here, the charger is working, correct? Now, you should have 18.5 volt on this line. This dot here tells you that pin 1 and 2 are what? Are the same. Okay, now, if you follow the line, the first component you see on the line is what? Is this, correct? It's a capacitor. Now, that capacitor, this dot tells you that the capacitor is connected to it, correct? Now, the capacitor, by nature, you have one side, it's connected to the line. The other side is connected to ground. This sign here is a sign for ground, correct? Now, if this sign here is connected, if this is ground, it means this line here is ground, correct? It means this line here is ground. Now, it also means that whatever is on this line is going to be ground. It means 4 and 5 of this line are what? They are ground. Now, on my connector here, my pin 1 and 2 is going to be the main line. What do I mean by the main line? That is where the charger voltage is going to come through. If I want to check for my charger voltage, I'm going to check. I can either use any component that has connection to the line is where I'm going to check. Now, we have 1, 2, 3, 4, 5, and 6. Now, the first check, my first measurement is going to be on my PPD's in, because you need the primary voltage before anything else will take place. After I check that, there is a pin 3, TDM 1 wire MPM. Now, that we're talking about a 1 wire. The charger itself, let's see that. So, look at the charger itself. So you have 1, 2, 3, 4, 5. The pin in the middle is this one. That is the pin in the middle, correct? Now, you see this 1 and 2, it's going to be your main. This, the first two, this or that is going to be your main. This and that is going to be your ground, which would mean that, so here you see that it says 1, 2, and then 4, 5, 4, 5, and then you have 6. Here, it's not going to be, so here, the first and the last is going to be the same, correct? The second and the third, and then you have 1 in the middle. Now, the 1 in the middle, which is how the 1 in the middle allows that however you flip the charger, it remains in its place. Because if, for example, if this was here, if you flip it, it will change. Do you understand? But because that one being in the middle, however you flip it, it still stays the same. So if you have, so let's say 1 and 2, let's say this and that, and then this and that, and then this in the middle. So if you flip it, the arrangement is still the same. Okay, so now the first thing we are going to worry about we are going to worry about the voltage on the main line. On the main line, we have a capacitor. On that main line, we also have a component here, which is a fuse. F, whenever you see the letter F, that's referring to a fuse. Whenever I see the letter C, that is referring to a capacitor. C is for capacitor and F is for your fuse. On that line, and this dot tells you that they are connected as one. So this dot capacitor is connected to this line. On that line, you have a fuse. Now that fuse goes and then it says equal to. Now from that fuse, you have a straight line that connects to R6912. On that same fuse, you have another resistor there. When you see R, that is your resistor. R stands for resistor. C stands for capacitor. Now this is a MOSFET. Q, that's a MOSFET. This is a logic gate, U6901. This is a logic gate. And then you have U6900, which is here we are going to talk about the adapter sense. Now so the first thing we're going to do is we are going to see what do we have on this line. So we can use C6905 or we can use F6905 to confirm if we have voltage coming from the charger. So let's connect our charger to it. Now, just by looking at my board, I will not be able to tell. Which components is C6905 or F6905. So what I then have to do is I then have to go to my board view. So on my board view, I go to J6900. This is my board view. Pin 1 and 2, we know that pin 1 and 2, it's our main line. On pin 1 and 2, we have components like we have D6970, C6905, F6905, and then we have a diode, which is Q6970. Now, wherever you see these dots, that is telling you that they are connected as one, correct? So we are going to start by, so we can use this capacitor or this diode here, or we can use this one to see if we have voltage on from our charger, and that's going to be on the other side of the board. We can easily measure that from the other side of the board. So we have our black, we want ground, our multimeter is set to voltage mode, and we can use this capacitor here, this one, and we see that we have voltage from our charger, correct? Now the next thing we want to do, so now let's continue. So we know we have voltage here. Now let us see, we know we have voltage on pin 1 and pin 2. Now let us see what is happening on pin 3 and 4. That's going to be a ground. Let's see what is happening on our pin 6. So let's go to pin 6 and see what's happening on pin 6. So pin 6 is going to be adapter sense. Let us see what is happening on pin 6 and where we can measure that. We can measure pin 6 on this guy here. Here we can measure pin 6 here. So the pin 5 of U6900, pin 5, we can measure for adapter sense on pin 5 of U6900, and that is this guy here. So let's have our black one ground and then our red probe. Let's see what do we have on adapter sense. Adapter sense is 0. Now adapter sense being 0, that can mean that we do not have PP3V42, because the logic gate here will play a major role in your adapter sense being present, because you have your logic gate. In your logic gate, you have SMC, BC, AC, okay? So the way logic gate basically work is it will say to itself, if A plus B is true, then let there be C. If you have A and B, then let there be C. So in this case here, you have A and B is going to be SMC, BC, AC, okay? So it's going to say SMC underscore BC. So SMC underscore BC underscore AC is okay, is going to come from that is the signal that is going to come in. Now in order for you to have, so you have A, B, You have A, B, and then Y. In order for you to have Y, A and B must be present. And in order for the logic gate itself to be powered, so if A and B is present, and the logic gate itself has no power, it will not be able to output because it wouldn't know what is happening. In order for it to be, in order for the logic gate itself to be active, to know what to do, you need to have power on pin 5 of it. If you have power on the pin 5 of it, and then you have A and B present, then you will have Y. Now, Y is what will now go to your SMCBC OK, which is a VCC, which is a requirement for your U6900. So, because we are having 0 volt on adaptive sense, we are going to now move to U6901 to see what is happening here. What are we going to check for? We are going to check to see that we have PP3V42 on pin 5. We are going to check that we have pin 1 and what? And then we have presence of 1 and 2 is present. And then obviously we know that because of this dot, pin 1 and 2 is what? Is the same, correct? Okay, so in order for this to be present, what do we need? We need this signal to be present, and we need PP3V42 to also be present. So now we want to go and find out what is happening by U6901. Do you understand what you're doing? So first thing we did was to confirm that we have charger communication. Yes, charger by charger communication communication is not fully established, but at least the fact that we have voltage here, it means that we have the charger is what is recognized and is connected. Now the charger is not fully active because our U6901 is what is not active. Now we measure pin 6. Pin 6 is 0. Pin 6 is supposed to come from U6901. We are not going to blame U6901, U6900 yet until we find out what feeds U6900. Do you understand? So we are not blaming this yet. We check this. We see that we have 0 volt. Okay? Now, we are not going to blame this yet. We are not going to blame. If we check that pin 6 is what? Is 0 volt. Now, the next thing we want to look at is where is that supposed to come from? It's supposed to come from U6900. Now, U6900, now the exit, which is the output of U6900, is supposed to give us adapter sense, but that is not present. We are not going to blame this yet until we go back and find out how is this supposed to function. The way this is supposed to function, the voltage, this is going to be activated by U6901. U6901 is supposed to have SMCBC AC OK and PP3V42 voltage in order for it to send out the VCC that is required for U6900. So right now we measured that we don't have adaptive sense output present. We are not going to worry about this chip. We are going to move to the requirement of this chip. So we come here. If we check here, if we don't have output, we are not going to worry about this. We want to check what is required for this to be active. So we're basically moving down the line. Okay. So now let's check U6901. The same U6901. The same thing. We are going to copy U6901, or we can just type it on our board view. So okay, U6901 is just here, correct? So that is U6901. Now U6901, we know that pin 1 and 2 is going to be the same thing. Pin 5 is going to be PP3V42. So let's here it gives us a summary of the chip. So pin 1 and 2 is same. 3 is ground, 4 is SMCBC AC OK VCC, and then pin 5 is PP3V42. Okay, so let's start by we are going to start by checking pin 5 because that is the power line that U6901 is going to rely on. If it doesn't have PP3V42, the chip itself is dead because it has no power to it. So let's see, do we have PP3V42? So let's just go back to this. So the first thing we are going to do is we're going to check to see if the chip itself has power. Now, if you look at pin 5, the information you have here, it says PP3V, so it says this capacitor is equal to PP3V42. What that means is on this line, you're supposed to get 3.42 volt. You understand? 3V42 means 3.42 volt. G3H means that this line will always be present, regardless of which power line, which form of power you have to this machine. Now, G3H, it's going to be always present. Generally, on your machine, you have two main forms of power. You either have power from your charger or you have power from your battery. Now, there are certain voltages that will not be present depending on what form of power that you have. Say, for example, PPDC in, you will say that PPDC in here, let's see, hmm, let me see. Okay, let's go to pin one. Let's go to the first page of this machine. We are going to come back to this place. So if we go to power aliases on pin 8, let's go to power. So pin 8 is going to give you the list of all of the voltages that you have on this machine. So it's on. Here it says power aliases. So let's go to 8. So we go to 8. Now here on this is where I want to draw our attention to. See here where it says PPDC in underscore G3H. PPDC in is a voltage that comes from the charger, and then it says G3H, it means it's always present. However, this will only be true tied to this. It is only true to PPDC in, not true across the board. What that means is if PPDC in voltage is not present, you are not supposed to expect G3, you are not supposed to, this is not active at that time. If you have a battery, for example, attached to this machine, this is not going to be present because this is a voltage that is going to come from the charger. Not so with a PP3V42. PP3V42 is supposed to be active regardless of whether you have a charger connected or you have your battery connected. Okay. So let's go back to U6901. Let's copy. So we come here. No, U6901. U6901. Okay. So here, you see what we are doing now. We are not going to worry about U6900. We move back to see how that is supposed to function. We come to U6901. The U6901 is going to remain dead unless we have power to U69 or U6901. So the first thing we're going to do is we want to see the power to the logic gate itself. So we go to pin 5. And pin 5, the chip itself, we say this is 901, so we can measure at either pin 5 of it, or we can measure by the capacitor beside it, which is C6908. So that chip, and obviously when you're measuring for voltage, you want to make sure that you actually have charger connected. Okay, so that chip that we are measuring for, so UCC901, this is UCC900, and this is U6901. Now that capacitor by U6901 is going to be this guy. Let's just confirm that that is the case. Yes, so that capacitor is this one, but this side is ground. The other side is what? Is the PP342 line. So so this side of it is going to be PP342 here, and we see that we have 0 volt. You see that? Now let's just confirm again that we still have power coming from our charger. We can check our fuse here. We still have power coming from a charger. Okay, now that we have 0 volt, what is the next thing to do? Now that we have 0 volt, it makes sense. Let's see. Now that we have 0 volt, now we understand why we don't have adaptive sense, because what is required for adaptive sense is not present. Now we go back to what is required for adaptive sense to be active. That's how we found our way by U6901. By U6901 is not doing this job, not because U6901 in itself is faulty yet, but because we do not have voltage to power U6901. What is the next thing we are going to do now? What do you think should be the next thing?
Because we found out that it's not giving the adapter sensor
voltage. Okay, yeah, adapter sense signal is not present. We worked our way back to how that is supposed to be generated. We worked our way back to U6901. Now we find that at U6901, the voltage on U6901 is not present, which means that our problem is not even U6901 yet, because U6901 power, is not getting power at all. If it doesn't get power, it's not going to do anything, because it's not doing anything. That is why we don't have anything here. Now, while we are here, now that we confirm that we don't have voltage, or we don't have power at pin 5 of U6901, what do we do from here? What do you think we should do? The 3.42 volts. So whenever you see something like, don't worry about a PP. So it's going to be, so here it's 3. So now you say 3.42 V. So you move the V to after, and then you put point here. So it becomes 3.42 volt. Now that we see that we don't have voltage here, what is the next thing that we do?
Like you said, starts here also, like at one of the pins, because here is a step down, right?
Yeah.
And then it obviously comes in here.
Yes.
And then it sends a volt. So now I must check now if this is sending the volt into here
now
to generate the volt that we need.
Okay, so because we don't have this, the next thing we are going to do is we want to find out where is this coming from. You understand? Before we do that, we are also going to check to see if we don't have a short on that line. Remember, if we have a short on that line, the voltage will not be present because the voltage will be making its way to ground, correct? So the next thing we are going to do is we are going to check to see if we have a short on that line. And then we are now going to check where is the same procedure. Remember, we are coming from here. We checked pin 6, we don't have the voltage. Where is it supposed to come from? U6900. Now, when we got to U6900, we check how is U6900 supposed to send out voltage? VCC, we don't have power, which is the power. That is absent. We go back to where is it supposed to come from? We come to U6901. U6901 is supposed to send out the voltage, the voltage or signal that we need for our VCC. That is not present. Why? Because we don't have power to U6901. Now, the next thing is, where is that power supposed to come from? Now we copy that, and then we continue moving back to, we are going to the source, where it's supposed to come from. Now, this is a power line, because see, when we were here, we did not worry about if it's a short, correct? We just moved, But when we got here now, that we don't have voltage here, because this is a voltage line, chances of us having a short on that line is what is high. Now, mind you, if we have, remember, there are multiple points of PP3V42 on the line. So if we have a short on that line, it does not necessarily mean that the short is here. Do you understand? No. So when I say here, we are only talking from this point to this point, which is this capacitor to the logic gate. We may have a short, if it is that we have a short, we may have a short with any other component or any other section of the board, but will be on that is connected to PP3V42. Do you understand? So I'm saying, if we have a short, it might not just be that the short has to do with this or this. Do you understand? So it can be anywhere of the board, and it can as well still be this capacitor. Now, the next thing we are going to do is, if you are looking for a short, always look for a component that has a path to ground. Do you understand? A component that has a path to ground. Now, obviously, usually your ground is what completes your circuit. Okay, so the next thing we are going to do is we are going to confirm that we have a short on this line. Before we do that, what do we do? Remember, we have power. We have power connected to the machine. Now, can we check for a short with power connected to the machine? No, we have to remove our charger now. So we are going to disconnect the charger, and then we are now going to use our multimeter. Now, to check for short, what are we going to set our multimeter to? Continuity. We will set our multimeter to continuity. There are two ways you can check for a short. You can use your continuity mode. You can also use your diode mode. Okay, so with one of the effective ways of using your continuity mode is because of the beep that you get. And I like to use my small meter because the beeps is very loud. So when I set it to, and then the sign for your continuity is this one here. You see that beep sound? That is your continuity, and then this one is your diode. This is continuity, and that is your diode. Now, if I do this, and it beeps, it tells me that my probes are equal, correct? So if it means that my probes are equal, if I place one probe on ground, this is ground, and then I place here also, it beeps, it means that I am connected to the same thing. Now, any component with this being on ground, any component that has two sides, one side should beep because if it's a capacitor, one side should beep. If it's a resistor, no. So resistor by default, not all of it will have a path to ground. Some will have a path to ground, some will not have a path to ground. Now, but if it's a capacitor, one side. So generally, when we're checking for a short, we generally use capacitors on that line because it's easier. Capacitors by generally you have one side being connected to ground and then the other side being connected to a line. So when we see any capacitor now, so any capacitor, when we check the first, for example, this is a capacitor, that's a tantalum capacitor. So if I check this side here, it should be, by the way, if you look at this capacitor, you see there's a plus sign here. That plus sign, this is a polarized capacitor. That plus sign tells you that that side is the main. The other side here is your main, and while this side is your ground. Do you understand? That's why you see the plus is on this side. So if I measure this, for example, it beeps because that is connected to ground, just like how this is ground. But the other side, if the other side beeps, then I have a problem because it's not supposed to beep. Do you understand? And then something else also you need to understand is this. Now, look at my multimeter. When I got a beep, what do I get? I get complete zeros, correct? On this other side, when I get a beep, what do I get? I don't get complete zero. So it tells me that it has a path to ground, but it's not completely shorted to ground. So that is going to be important when you are measuring on your CPU vCore lines. Okay, let's not talk about that. Let's worry about why we are here. So the next thing we're going to do is we're going to check to see if I have a short on our PP3V42. So that same capacitor that we use, this was a capacitor, correct? So we know on the capacitor, this side is supposed to be ground. The other side is supposed to be your PP342 line. And we don't what? We don't have the short. Okay, the next thing we are going to do is we are now going to, so now that we don't have a short, the next thing we're going to do is we want to find out how is this line, where does PP342 come from, correct? Where does PP342 come from? So what we are going to do, because we're looking for PP342, now we are looking for PP342, we are not looking for we're not looking for this. We're not looking for this, we are looking for PP342, correct? So we are going to copy this, we copy that, and then paste it on our what? Paste it on our search. So you come to our search, you paste it there. So I paste it there. Now it says found on 11 pages. Of these 11 pages is where that voltage is going to be generated from, correct? So I copy and then I paste. The same thing applies. If I copy that and I paste on my board view, it will show me all of the points where PP3V42 is present. If I copy and paste on my schematic, it will give me the number of it will show me the pages, or it will list out the pages where PP342 is what? Is present. Of those pages is where the voltage itself is going to be generated from. Now, the one thing to understand of these pages you will find where PP342 is going to and where PP342 is coming from. We are interested in where it's being generated from, not where it's going to. Okay, so we are not going to copy. If we copy that and paste on our board view, it's only going to show us the point of PP3V42, but it's not going to show us where it's coming from. Myself, when I copy and paste it there, I would know because I have already known. But then for somebody who is trying to understand how it's been generated, they wouldn't know. So it says it found on what? On 11 pages. So let's start by going next. Now, the first time after copying and pasting, what we will get is we will get a summary. We will get a summary of how that voltage is generated. Now, if you look at that, so here it says power block, it says power block diagram. If you look closely, here you have, what do you see here? You see, it say U6990 happen to be that sign here. You see, see that sign? That tells you that it's coming from U6990. Do you understand? So this, whenever I see that, it tells you that it's coming out from U6990. This is another very, you see the drawing here. This is a block. You see that? So it's coming from, see, V out, voltage out. The same thing here is coming from. So just from the first copy, we can tell that it's coming from U6990. We can just go straight to U6990 without having to go next. But for simplicity, let us go page by page. So the first search you do, it gives you the block diagram, basically like a summary. Then it tells you exactly where that voltage is, what is being generated from. So here, the next thing we are going to do is let's now follow the page. So the first one, let's go to the second one. Here it says you see that is PP342. It's not, it just says true. That is not where it's coming out from. We are interested in where that voltage is coming out from. If we look at what this page here now, on this page we just have through PP342 line, PP342 line, PP342 line, but it does not tell us where it's coming out from. So let's go to the next one. Next. Now here, this is a page that gives us, so it says PP342 reg. This is where it's going to be. This is basically regulation or regulator. It's equal to all of this. But is it? And also the good thing is, you see where it says PP3V42 underscore G3H, correct? What that means is voltage 3.42 volt. You understand? What that means is 3.42 volt. That is what you're expecting to get on this line and all of that is connected to it, correct? It's not being generated from here, so we are not interested in this page. So let's move on to the next one. We just go next. So that was too quick. So this is the next page. Now this is PP342 going into something, correct? It says equal to, correct? It's not being generated. We're looking for where it's coming out from. Okay, let's move on to the next page. The next page, do we have, let's see. Okay, this is also where it's going into something. It's being used to power something. It's not coming out, correct? Okay, so let's move on. Here is also where it's being used to power something. Okay, we go next. Here is also being used to power something. Here is being used to power something. We're looking for where it's coming out from. We go to next. Here is also is just used as a pull-up. That's not where it's being generated from. And here is also going into something. This is not where it's being generated from. Okay, let's continue. Here is the same thing. We are PPT. Remember, this is where we started our troubleshooting from. Okay, so that's not. And then you have here PP342G38 is also going into something. That is not where it's being generated from. But then if we look down here, we see it where it says 3.42 volt, 42 G3H supply. This is where it's being generated from. And remember the one that we saw before, U6990. Now this is the chip that creates or that generates your PP342. Now U6990, what this is going to do, this is basically going to take a high voltage and split into a low voltage, because what you will get in here, you see what comes in. Okay, let's quickly go back. So this is where our troubleshooting is going to aim at. Now another thing is, usually when you have a buck converter, there will be an inductor. You see this whenever I see that is an inductor. An inductor you have L for an inductor. Whenever you have a buck converter, you always have an inductor at your output. You understand? So it takes a high voltage and then it switches it, and then you get a low voltage. You get a low voltage. Now that we are here, we know that this voltage is going to be generated from U6990. Now the same process that we followed before is the same process we're going to follow here. The question we are going to ask ourselves: how is U6990 supposed to function? We look at the pins of U6990. Now we have Vin, that is voltage in, correct? Remember how we remember on the logic gate that immediately we didn't have power, we just moved out, because if there's no power, there's nothing else, there's nothing to worry about. So here, the first thing we are going to do is we are going to confirm that we have power to U6990, correct? After we confirm that we have power to U6990, we are also going to confirm. We have here the pin that says the shutdown pin. So shutdown, we have shutdown, which means to shut the what? The chip itself down. Now, we are going to also make sure that we have voltage at the shutdown pin. If we do not have voltage at the shutdown pin, it would mean that the chip itself will be off. Pin 7 is NC, which is not connected. So pin 7 is what? Is not used. Now, pin 5 and pin 9, they are the ground pad. Thermal pad, ground pad, pin 5 and 9. So that is by default 0. Now, feedback, FB is your feedback pin. Now, your feedback pin, remember this chip here, it's supposed to output 3.42 volt, correct? In order for this chip to work efficiently, it needs to know what its output is. So the feedback line is connected to the output. You see, it's not connected to before the inductor, it's connected to after the inductor. So that way, this chip is able to regulate and understand what is happening at the 3.5 volt line. So, and this feedback pin is going to be more like the eyes of this chip to function. What that means is if you have a broken line on your feedback line, your PP342 is not going to be active. Why? Take an example of when you're driving and you can see what is in front of you. The moment you're not able to see what is in front of you, what do? You want to stop. The same thing applies. This chip's eyes to what's happening here is to the feedback line. If you have a break in line, if this chip is not able to tell what is happening here, the chip will not output PP342 because it will assume you have a problem. That is your feedback line. Now, this is the switch. Now, the switch, you have the switch and the boost. So the switch is basically where it switches 0 and then it keeps basically slices the voltage into and then eventually to output what? Your 3.4 volts. So our first thing we're going to do is what are we going to do? We're going to start by checking to see if we have voltage on our V-in pin. Now, here on the voltage on the V-in pin, we see that don't get confused by the many lines that you see. What is the main line here? All of these are capacitors, correct? And here it says no stuff, meaning the capacitor is not on the board, correct? So C6997 is not present, C6996 is not present, C6993 is present, C6992 is not, C6991. Now, these capacitors are going to act like a battery. Do you understand? They will, this voltage, whenever the voltage that comes here, they will have to store it so that because in order for PP342 to be regulated, you need a constant supply of this voltage. You understand? So just as this is coming, then this will save some of the capacitors and will save some of it so that you can get constant supply of your voltage. Now, if you follow that line, here we said those are capacitors, correct? So we move down. We don't have to worry about that. Now this is a shutdown pin. We must have voltage here, otherwise the chip is going to be off. Just the same way we must have voltage here. Now, how do we get voltage here? The voltage is going to come from a diode. This diode has dual input and single output, correct? It has dual input, correct? And what? And single output. Now, here it tells you how important that chip basically says is what? Is critical. Now, the dual input, you have one that says PPDC in. Whenever you see DC in, that is charger, correct? PP bus is going to be from your battery. Now, this diode can either take voltage from your charger or take voltage from your battery to create your PP342. Do you understand? Okay, so now that we're here, what are we going to do? Let's see, what do we have on what? Where do we start? Power, correct? Let's see if we have power on pin 6. So we are going to go to U6990. We've already confirmed that we don't have a short on our output of PP342. The next thing we're going to do is let's go to U6990 to find out what is happening on U6990. So we go to our board view and then we can type U6990 on our search. So we search to see where U6990 is. So U6990. Now, it's important to have a board view because the board view is going to tell you where your voltages, where the components are located on your board. And so now this is U6990, is close to the battery connector, correct? J6990 is close to the battery connector, which is J6950. So we are going to flip our board to the other side, locate the battery connector. This is the battery connector, and J6990 is going to be this guy here. So this is U6990, correct? That is U6990. Okay, so U6990, let's now see what is happening there. Let's flip it like this. This is U6990, correct? Now, that inductor that I showed you, that is the inductor. Yeah, that's the inductor. Now, we want to check, we want to start from pin 6, correct? We click on pin 6 and it will show us where that's present. So now all of these dots tells you where pin 6 is present. So what are we supposed to get? We're supposed to get, now we are supposed to get the voltage from this diode here, depending on what we have, what form of power we have. By the way, this is not correct. You see where it says PP bus is 18.5 volt? That is not correct, because this is battery. This is correct. This is PPDC in. PP bus is going to be 12.6, 12 point something, not 18 point. So this is not correct. So because we have charger connected, so we are going to expect the voltage that we have on our charger. Remember when we started, what were we getting on PPDC in? 16 point something volt, correct? So that is the same thing that we're going to expect from here because of its DC in. So we are supposed to expect PP3V42 16.5 volt from our what? From the output of this diode, which is what we are supposed to get on what? On your pin 6, correct? So now let's go to pin 6. So we just copy to see. So we are going to check. We can use this capacitor here, this point here, to see what we have on pin 6. So let's see, how do we flip that for easy access? So let's flip it like this. Okay, that's pin 6. So like this. So the capacitor that we're using, this capacitor here, this is the chip. This capacitor here is going to be this one here. This one, that capacitor is going to be that one, correct? This side is going to be ground, that's going to be main, and this is the 6990. Okay, so, and obviously in order for us to check for voltage, we must make sure we have what? Power, correct? Okay, we must have power to the device. So let's connect power to it. Charger is connected. You just always want to make sure that indeed you have your charger voltage. So we are going to now see what do we have on this capacitor here. What do we have? What do we have? Look again.
It's 17. It's going up and down. Fluctuating.
What do you have there?
0.4.
Where did you see 20 volt before? Okay, so we're getting what? 0 point something. So is that a problem? Yes, it is a problem, because we know that what is the voltage that we're working with? What voltage are we working with from the charger? What voltage are we working with from the charger? No, that is what is rated for the device. The charger that we have, what is the voltage that we have from the charger?
The one that we got.
The charger itself? No. Okay, let me measure it again for you to remember. Correct, it's 16.5. I'm just going to show you again so that you see it. Correct? 16 point something volt. Okay, so if we are having 0 point something volt here, what are we supposed to have here? We're supposed to have 16 point something. What we have, remember, from the charger, correct?
Yeah.
We're supposed to have. Now that we have less than that, what are we then going to do? Yeah, we move back to find out why. Correct? I mean, we're supposed to. So we know already. We know that this voltage is present. 16 point something volt is present. Correct? Now we now want to come. We are now going to check the diode to see if it's present. Okay, now this is it. We want this voltage here, correct? But the voltage is not there. We're getting 0 point something, which is less than what it's supposed to have. Now the next thing we're going to do is we're going to take a step back. Does it come into the diode itself? That's what we're now going to check. Is it coming into the diode? If it comes into the diode, but it does not come out of the diode, two things. It's either the diode is faulty or we have a short on that line. You understand? Remember, you keep taking a step back. Keep taking a step back. We're supposed to have voltage here. We check. We have less than what is required. Where is that supposed to come from? This 6905. This 6905 is supposed to get 16.5 volt from our charger. Now, since we're getting less than that from the input, we're now going to go back and see, do we have it on input? So we're going to check the pin 1 of this 6905. So let's go to this 6905. Let's go to our board view. So where is our D6905? This is D6905. So it's actually closer to the chip itself. So let's flip it. So just to recap, so we try to measure from this cap here, and we got 0 point something. So typically it's not present. The next thing we now want to do is we want to see if it's present on pin 1 of D69. D69 what? 05, correct? So okay. So now here we see that the pin 1 is also connected here. So if we don't get room to measure on this here, where can we measure it from? We can also measure it here. So let's see if we have it here. And this is 905 is this. That is the diode, and we can measure it here, correct? Okay. So let's see. So if we measure it here as a pin 1 of it, what do we get?
0.25.
You have to open your eyes, eh? Open your eyes and stop saying things that are not true. What do you have?
0.25.
Exactly. Okay. So if we have 0.25, what does that tell us? If we have 0.25 here, it means that we again have to take a step, correct? Now we want to check R69. Remember, voltage comes into R6990, which is what? What is R6990? A resistor. Voltage comes in, is supposed to go out to D6905. If we are having 0 point something volt here, we move back to check what is coming in, and we're getting 0 point something volts there. What are we going to do? Move back to see what is going into our R6990. So what our R6990 is attached to, it was the same resistor that I was saying, if we are not able to get room to measure it there, we can measure. So let's now see what is happening on that resistor. And if you look at that resistor, we can actually see that it has a burnt mark. So this is the resistor here. Can you see how it looks like it's burnt? Actually, not just so, that is burnt out, and even that looks burnt out. Can you see both? Let me get another board for you to have an idea how it's supposed to look. Can you see how it's supposed to look? Can you see the difference? Okay. Now let us see. We know that we are getting less voltage here. Now, what about the other side of it? The other side, which is this side. Do you see that? So the other side of it, the pin 1 of it, we have the 16 point something volt that we're working with, but the other side we have what? Okay. Now, while we are here, there is something that stands out. Okay, so let me disconnect. Okay, let me explain from here first. The voltage that we're supposed to get here is low. We move back, we found here, low. We moved back. Output, pin 2 is what? Is low. We move back, the voltage is what? Is present there, correct? Now, the fact that the voltage is present here, it means that our problem is from this point on, correct? The first thing we're going to do is to check if we have a short. The same thing, do we have a short on this line? The fact that we have a burnt mark here and also here, not just here, we also saw that this looks burnt out. it suggests that it could be that something that is common to these two lines is shorted to ground. And what is common to these two lines is the output, not necessarily this. Now, sometimes what happens is if you do have a short on this line, sometimes what happens is after you address this line, this will also be damaged. The fact that if we have a bound mark here and a bound mark on this resistor, it suggests that we could have an issue that is common to this line that has affected both, which would mean that we could be having a problem on this line, which will also affect D6905. The next thing we are going to do, we are not just going to replace these two. We are not just, remember, primarily we are only interested in this. This is our PP bus line, but also we would be needing that. Otherwise, you'll have a machine that will power with your charger, but will not power with your battery. Do you understand? Why we're here is because we don't have, because of the voltage that we're supposed to have here is missing. So we are not just going to replace this. First thing we are going to do, check this line. Do we have a short on this line? If we don't have a short on this line, we check this line to see if we have a short. If we don't have a short, then we can replace this and that, and then we should be good to go. So we disconnect our charger, and then let's now see if we have a short on that line. So black probe on ground, and that's the output of this, is correct? So let's see. We don't have a short, and then on the other side, okay, so we don't seem to have a short, but now this is where diode mode comes handy, because sometimes the figures that you get, especially this is handy when it comes to getting to hear beeps. Now this is where diode mode comes handy. Now I'm going to use my diode mode because I want to compare the value that I'm getting, not just about beeps. Now I want to compare the value that I'm getting. I'm going to switch my multimeter to diode mode on this one. Diode mode. Now I want to see what do I have. What do I have there? Now remember, with continuity mode, the probes placement don't matter. Diode mode, it does matter. For diode mode, the red probe has to go to ground and the black probe. And why am I using this? Because this will give me accurate. I need to have something accurate now. I have my red probe on ground, and then my black probe I put in on that line to see what I have. I have 0369. I'm going to take another board and compare that reading to it. Red probe on ground, and then my black probe, and the board is liquid damage anyways. Okay, and then we see that is fine. Now we're going to check this side as well, OL, and then this side, OL. So let's check what we have. OL basically typically means open line. OL, and the other side. Okay, that's fine. That's fine. That's fine, not a problem. Obviously we might not expect accuracy because we see that the body surface is liquid damage. Now that we see that we don't have a short here, the next thing we're going to do is we're going to replace this and that. We could just replace this because we're busy with that, but let's replace both. Now we confirm that we don't have a short, so it's fine to just go ahead and replace. Now when you see a component that is burned out, yeah, or when you see a component that is supposed to output a voltage, or voltage is supposed to go through it or pass through it, and that voltage is not present, before you rush to replace it, make sure that you read to confirm that you don't replicate the same issue. For example, if we don't read, let's say we have a short on that line, we don't read, we just replace the component, the same thing is going to happen. If it doesn't happen immediately, it's going to happen along the line. Okay, so let's replace that resistor, and we read again to check what is happening. Remember, our primary problem is this guy here, not this guy. But we're only replacing this because we also see bunch mark on it. That's the only reason why we're replacing it. Okay, that's replaced. And now the next thing we're going to do is we are going to give it a bit of time to dry, to cool off. Okay, so um, remember why we found ourselves here. We started from the PPDC in connector, and then we moved our way down here. If we connect the charger and then we have LED, it means it worked. So we don't have to worry about having to measure all over again. But then, but if we connect the charger, it doesn't. We still don't get LED on the charger. Then again, so let's connect the charger. See. Oh, before we do that, let's just confirm that we don't have a short on that line again. Left probe on ground and then a right probe. See, that's fine. And then the other side. Okay, that's fine. Okay, so let's connect charger to it. And by the way, because it's an original charger, delay is expected. Okay, okay, we don't have anything. And then I can hear something burning. Okay, I hear something burning. You see what happened? It just burnt again. The resistor that we replaced now just burnt again. Yeah. So how interesting is it that even though we didn't get a short on that line, there's actually a short. So we're gonna remove it again and replace it, but this time we are gonna do something different. Let's get another board. Okay. So now, as you know, so what's happening is we replace this two, and then we try it again. Obviously, it burnt out again. So R6920 burnt out again. So which means that something after it, correct? There's a problem with something after it, not before it, because here it's true, we have voltage here, but after it, it keeps, yeah. So what is after it is D6905 and U6990. It's not a PP342 line because you confirm we don't have a short there. So our problem is going to be either this guy or this guy. If it is this guy, most likely this is also dead. So we have to remove UCC990. Let's remove UCC990. Okay, UCC990 is out. So what we can do is we can test it now or we can just replace U6990 first. So we can test it first, and then if it works fine, then we just go ahead and replace U6990. Obviously, we are not expecting the voltage to be present, but at least we want to see that, we want to see if it's still if it stays without burning. Still burns. So what else can be? Yeah. Okay. Okay. Let's try it. Okay, let's see. Let's see what we have on the input and output. Beginning, what do we have? 16 volt on the other side. 16. So we need to replace that and then that. But then we're not sure if the problem was this guy or originally the diode. So what we're going to do is we're going to put back that, just replace diode only. So let's put in another diode. But yeah, so to be safe, we might want to also replace. Are you able to see from there better? Because if it's blurry, it's not because of the position, it's because of how you're holding the camera. Okay, I think to be safe, it's better for us to just get another one. So if you are going to get the board, if you're going to get your this from a direct donor board, then you don't have to worry about the orientation. But if you're going to get it from a different board, like if you're going to get it from this one, we have to understand the orientation. Yeah. So usually you have a small let's see. So pin one is going to be this side. Let me see, is that? No, pin one is on top. So pin one is this side. Okay. So going to also make sure that we have the same orientation. Okay, so this one we'll have to flip it. So with this one, the pin one, it's this side. Whereas with this one, the pin one, it's on the top. So we have to flip it like this. You understand? Yeah. And then another thing I'm going to do is to be safe, I'm going to replace C6991 and C69. So to be safe, I'm gonna have to uh, just see. Let's see. So let's see. This so let's see if we can that. Let's look. So this is present, but this is not present. So I think it would be better if we replace that as well. Even though it will also be good if we replace that, but let's replace that one first. Okay, so far we have replaced that the capacitor, the diode. The other register the register looked you see it has a bunch mark. That's the one for the PPDC in. We are going to replace that. Even though remember we did try it and then we saw that we have voltage across it. But we are still going to replace it. It will be best I will replace it. Yeah, so it will be best I will replace it. But for now we just wanna so after the burn after the smoke that we got, we obviously had to remove and replace the diode. So now we have diode replaced, the cap replaced, and then so let's just check to see we don't have a short. Even though we did check before and we didn't get a short on that line, but still, let's see. Okay, let's try now. Nothing burns again. Okay, so nothing burns, but still we don't have communication. So right now, let's see what is it that we have. Let's see what do we have. PPDC in across across the resistor. We have 16.2 and then out. Okay, so um, let's replace the resistors too. Have to get another board. Okay, sorry. Okay, let's try again. So it doesn't burn again this time. Mm-hmm. Still burns out. Okay, before we go to replace that, let's check on that line. So what and what do we have on that line? Uh, so from this point to this point, what do we have on that line? So we have already replaced that, and we seem to still have a problem. So we we need to now replace so this C6993, C6991, and C6990. So let's see what this is. We know we did replace this one. This was replaced. Let's see what these two are. So C69, let's see what's happening here. Let's see. 93, let's see, so 91, 97, 97 is not present, 91, 93, and then the other one, let's see, the other one should be on the other side of the board. Okay, and we have two. Okay, so I think we should actually start by replacing the two on the other side. Okay, these two are not present, so it's just this. These two are not present, so it's just that. Let's remove that. Right now, we're not going to worry about replacement. We're just going to remove to see if that's where the problem is coming from. Move it aside. And then the other one. Let's see, on the other side. On the other side, we also need to move this aside. Okay, so which is this guy here. Mm. Okay. Let's try it again. Okay, so let's see. Hmm. Okay, so we hope that this is going to be the last resistor that we replace because there's going to be the fourth one now. Sorry. Okay. Let's just check again. So if this keep burning out, it goes through day 6905. Okay, let's check again first before. Okay, so now we have LED and the fan is spinning. So one of these capacitors, now we have LED. We definitely have PP3 before too, that's why we have LED. So one of these capacitors is a problem. And it's interesting that even though before we replaced, we tried that we don't have any short on the line and we didn't pick up any short, but still okay. As you guys can see now, we have LED and we have fan spin, so both is fixed, but we are going to put back the capacitors, two capacitors. We're going to put that back, so this the one we got from here and the one from the other side. We can use this same rating. And the other side. So here what I did was I just had to move the capacitor out of the line. You understand? You know, by one part only being on the line, then it's no longer active. You understand? So even if the problem was that one, the fact that the other part is not connected to the other side, it means it's not active. Okay, so let's quickly do a recap. Okay. So we started from G6901. We did have the PPDC in voltage. We had voltage here, and we were expecting voltage on pin 6 of GCC900, but that was not present. We decided to trace it down back to the feed of ECC900, which led us to ECC901. ECC901, in order for it to function, PP342 obviously need to be present. That was not present. We then had to narrow down where PP342 is generated from, which led us to UCC900. At UCC900, we found that the two resistors were burnt. They had burnt max, so we had to replace them. After replacing them, we replaced UCC900 and DCC905. But trying it, but then we applied before we then apply power to it. But before applying power to it, we made sure that we didn't have a short, and then but then when we apply power to it, R6920 burnt out again. So we replaced it, and then we tried again, and then it burnt out again. We replaced it for the third time, we tried it, and then it burnt out again. So what we decided to do was to replace all of the capacitors on the line, because we knew that we're having a problem from this point, because not from here, because here we were getting the voltage coming into the resistor, but from this point to this point we were having a problem. So we then have to check what are those components that are connected on that line. We thought the problem would be D6905. We replaced it for the second time, but that didn't fix the problem. So what we then had to do was to look at components after D6905, and those will only be especially components that have a pass to ground, in this case capacitors. So we then had to look at these components here. This is no stuff, that's no stuff, which is not present on the board, but this was present, so we replaced that. We replaced, the first thing what we had to do was to replace one first, but then it turns out that the one that we replaced was actually not a problem. So we then had to again go ahead. After replacing for the fourth time R6920, we decided to remove all of the capacitors on the line that were left. So after we removed those, we tried, it worked, and then we decided to then put them back. So we're just going to test it now for just to confirm that everything is up and good, and then check to see that we have image, and that will be it. Okay, so we see that we have LED and the device is starting. So let's just confirm that we have, because we saw that U8900 was attempted on the board. We are not sure why that's the case, so let's hope that U8900 doesn't need any type of touch-ups. Usually if you have a problem around U8900, or you will the device will power on but you have no image. I'm just gonna have at least one speaker connected. Okay, that's good. We have a chime, and we have light on the screen. So let's see, any moment from now we should have a blinking folder, because we don't have the driver connected. Waiting for blinking folder. Okay, that's it guys. Thank you guys. I'll see you guys in the next one.